Awesome. Hi, everyone. All good. Everyone's doing well. Okay, so first talk of the day. Let's start with designing APIs for React. Um, let's see if the slides work, and they do. So it's going to be talking about sort of how we shipped an SDK for React, and the overall theme is sort of talking about challenges we faced having like a JavaScript SDK and adapting it to React. What are the differences? And why you should care is probably because anything that you're writing in React that exposes an API, so be it like a component that your team uses, say you're building a SaaS that you want to, provide people with an SDK or some sort of an API. All of these patterns are sort of challenges that we faced. Knowing them in advance would sort of help you write better code, hopefully. And it's good. It's the first time I've given this talk, so like a lot of the ideas are a little half-baked. So if you don't understand some of them or have questions, please feel free to raise your hand. Let's make this like an interactive thing. It's not a conference, it's a meetup. Ask questions. If something isn't clear, I'm happy to sort of walk over it, discuss. If you disagree with something, happy to discuss. So before getting started, I am Ekaansh. I've been writing JavaScript for about 10 years now. Working as a developer advocate at Agora. I also maintain their UI kits and the upcoming React SDK that I'm going to talk about. You can follow me on Twitter. And most of the things that I do are open source on GitHub. So including these slides, anything you want to find out is on GitHub there. So let's start with a very important question, right? Do you know how to drive a car? Show of hands. Okay, most of the room, or at least given some time, you can conceivably expect to learn how to drive, right? Second question is, do you know how each individual piece of this complex system works? Hands, show of hands? No one? How the engine operates, how the transmission works, all of those other things that I don't know about. This sounds like an absurd question, right? But the idea to sort of ask this question is this is by design. Cars expose a damn great API, right? You just need to know how to sort of accelerate, deaccelerate, and steer. Everything else you don't have to worry about. So cars are a great example of doing APIs right, which is to say that you know the fundamental aspect of how to interface with the system, but you don't need to worry about the underlying complex architecture of how the system operates. So APIs, application programming interfaces, we've all learned about them. I sort of like to define them as it's a way for you to interface with the software or interact with the software without having to understand the underlying complexity of the system. A good way to think about APIs is it's just a big abstraction on top of an existing piece of software, right? And with computer science, everything is an abstraction. So we built out CPUs which process ones and zeros. Ones and zeros were hard to like write by hand, so we decided, hey, we'll do assembly now. Assembly was hard, so we decided to build programming languages. Those were, again, a bit hard, so we built libraries to make writing code easier. And all of these sort of expose some sort of an API which abstracts the underlying complex system, right? Like 0-1s are abstracted by move and multiply and jump in assembly. Those are abstracted by nice syntax in high-level languages and so on with libraries. And that's probably where we are with writing user code, at least till the AI revolution like takes over everything. Sort of what I'm talking about is, in terms of JS, is you have your V8 engine, which provides you some APIs to handle stuff like your file system, interfacing with memory. But that isn't enough to sort of give you like an API to write actual application code. So we built Node, which is the sort of framework to give you access to the aforementioned things that I just mentioned. And writing a server in Node is complex. So we built stuff like Express and Alicia and Hono and all of those cool things. And that's probably where the application lives. So this is just to explain that APIs are super important. They're present everywhere. A good API is invisible. You don't need to worry about it and think about it. And taking the example of React, you can think of your browser as like the base layer where we have React. And if you've ever tried to write an API in React where you're like data fetching, you quickly run into problems. How many of you have used React query? Show of hands. It's almost second nature, right? We're all pretty much jumping to React query without having to like maintain your state, maintain a cache, update your state if something happens, do error handling, all of those cool things. React Query just abstracts all of those complexities away, and it's almost the de facto standard to like write data fetching code in React. Um, all good. Like everyone's like really quiet. So any questions? Does that all of it make sense? Like what are APIs? Why are those important? Cool. So hopefully we're convinced that React is cool and APIs are important. So what makes a good API? And I could present you a list of, hey, it should be extensible and it should be flexible, it should be easy to use, and you should have some granular control over how much you abstract, and it should be, each action should be atomic in the sense that something shouldn't influence something else. And if an action happens, it should either complete in entirety or it should like error out without doing other things, which all of those cool jargon things you can learn in like a software engineering class. I have a talk about this, about building the right abstractions. The key idea there is finding the balance. This is a cool XKCD comic, which is like, you can either focus on the details or have the big picture in mind. And it's a dial which you're rotating either way. So a good example of this is you can have a really easy to use API where you just call one function and it does everything, but that isn't flexible. And something that isn't flexible gets thrown out rather quickly. So with all of these things, it's a matter of finding the balance. I have a meme here, which hopefully it loads. The frame rate is a bit bad. It's a dog balancing a bunch of treats. And if you keep building layers on top of each other, it eventually breaks and falls down. So it's about finding the balance. If you want to learn about like these jargony bits and what those mean, I have a talk that I spoke on one of the React meetups in the past. Happy to discuss that if you have watched it or watch it later at some point. But what I want to do today is sort of take a case study and instead of talking like high-level ideas, sort of show you exact problems that we faced and sort of how we overcome them and sort of just a journey of building an SDK. Why should you care is sort of all these things. I hope you're all convinced, or I can like go about sort of talking over these points. All good? Cool. There's a cool meme. It's also on my phone case. I really like this meme. Cool. So before talking about our particular problems, let's look at a few APIs that we'll talk about the high-level ideas that I'll talk about in the future. So how many of you used React Native Skia? Cool. So something I can talk about, not a lot of people. It's a sort of library for you to draw graphics in React Native. So if you want to do like cool animations, you can use Skia, which is like a C++ engine that these people at Flutter use to sort of build all their UI. It's extremely performant. And like you would know, C++ is an imperative language. Do we know what an imperative and a declarative language is? Show of hands. Okay, let's take a quick aside. So in an imperative language, code executes top to bottom. So like your Python, where you do let x equal something, print x, like everything happens line by line. React isn't like that, right? Like your hooks exist in some flow. It's not guaranteed that they'll be executed in order. There's no guarantee how many times the component would reactively update. So in React, we describe the UI and the framework takes over the rendering and the life cycle of the application. So in an imperative language, you say stuff like, should I bump up the font or is it like legible? Cool. So you have like a function which does stuff like create a color, set the color, draw a circle, create another color, set another color, draw another circle. So this all happens line by line. It executes normally, but adapting this in React would be complex. Do you agree? Do you disagree? Because you would have to like write a use effect and do like fancy things to get it working. We'll talk about all of those problems in a second. But what Skia does, which is really, really nice, is it gives you a very easy to understand declarative API. So you have your React components that you can just describe your UI, and the engine sort of hides away this complexity and manages how a circle is drawn, when it is drawn, how the color gets picked, how it's allocated memory. You don't have to worry about any of it. You just say, I want a circle, it draws it out. Does that make sense? This is the biggest challenge that React has coming from an imperative way of doing things in JavaScript. So think jQuery, think any sort of vanilla JS-like framework. You would be describing steps and functions. And if you're adapting it in React, you would be wrangling like refs and use effects and all of those complex challenges open, which we'll discuss. What I also want to show you is this is sort of the declarative approach, but you can assume that at some point, imperative code is more flexible in the sense that since you control the life cycle of what when happens, you can optimize stuff. With React, it might not be as flexible, right? And what Skia does is instead of saying that, hey, if there's a challenge that you're facing with your, declarative API, it's not that you have to like throw away all of this and go back to sort of this syntax. It gives you a component called drawing, which takes a function which can execute like imperative code. So for most things, you'd be writing declarative, familiar React-like syntax. And if you're doing something incredibly complex, which isn't possible with that syntax because it has its limitations, you can also always go down to the lower layer of writing code, which is imperative. Okay, lots of jargon, lots of complex ideas. Another simple idea that I want to talk about is how many of you have written some sort of Swift code? It's very similar to React Native. Show of hands. Cool, like this single line is fairly easy to understand. It's a component called image, and you can chain properties on that image. So think React props, but instead of writing like an HTML like syntax or JSX, you just chain properties on the function method. So image is a function which returns something, which we chain with some padding. We can make it resizable and we can scale it to fit whatever our component is. And if you're coming from Swift UI and say writing React, you'd be tempted to do something like this, where you have an image component and you're adding props to it. So padding is a prop which takes a number, like let's say 100, and resizable is a true false value, scaled is a true false value. So you can just add these props. Can someone spot what the problem is here or why this is not great? Yeah, so that's exactly it, right? Like you would be confused because when someone is writing this API or using your library tool, whatever, they would expect to pass padding to the style because that's part of the standard that React works on, right? So it's the browser standard where we pass in a style and we expect this to work. This can work, but it's then forcing the user to sort of learn your way of doing things. Does that make sense? Do we agree? Do we disagree? Even though this looks like a nicer API, it's something I wouldn't recommend you to do because then people would try this and stuff wouldn't work, and that's just not a good DX. Another example, and sort of I want to do two examples and sort of show you the difference, is there's this thing called gifted chat. It's almost the best way to write like a chat UI in React Native. This is sort of the API it exposes, right? There's a component called gifted chat, and it takes a bunch of props, and I can scroll the list for you. And this is hard to maintain. Like, do you agree? Like, all of these props make it extremely flexible and customizable and all of those cool things. But this sort of system is so hard to maintain for the developers that, yeah, at some point this will stop scaling or this will stop being flexible and like open a can of worms. This isn't to say this library is bad. This is a great way to design libraries. So they probably started with 3 props. Someone opened an issue. Hey, we want a way to customize the chat color. And then they were like, cool, we'll just add a prop there. And that kept happening. And now it's this. And this is like an old screenshot, so it might have gotten worse. Like, I don't know. But the idea to take away here is if you're clear with the domain, you can sort of forethink what all different challenges you'll face. And that's sort of what I'm going to talk about and sort of keep in mind some of the gotchas that we've seen. And one library which does things really, really well is called Recharts. Recharts, has anyone used? Right? Recharts is really famous, really popular. And what it does, it just asks you to compose things. And if you look at the new React docs, they're like, React is nothing but components that you can compose together. And it goes to that really fundamental idea of defining, fundamental components. So let's say you want to build a line chart that can contain your x-axis or y-axis. You don't have to do something like prop x-axis equals true, you can just omit the component and it's less code. You can add a legend, remove a legend. You can add a line. You can add multiple lines. So your line chart could contain 100 lines. It could be dynamic. You could take an array and map those lines and do like all sorts of cool things. So this sort of pattern or composition is great. Like this, that's just the key idea. This sort of pattern opens like a bunch of cool, like neat tricks and feels very React. Not to say that the previous thing wasn't React friendly. It was extremely React friendly, but you can sort of understand what the difference is here, right? Before we go in here, like any questions, anything that's not clear, something you disagree with? All good? Okay, cool. So this is like the meat of the talk today, right? And like quick warning, there'll be a lot of code, and I'll sort of talk about a lot of code. So if anything's not clear again, like feel free to stop me. So Agora builds real-time SDKs, real-time engagement SDKs for all major platforms. We have SDKs for web, Android, iOS, Windows, React Native, Flutter, all of those cool things, right? And building for web has sort of taken a big shift. And what I mean by that is, if you want to convince your manager on what I'm going to say, this is the graph to show. This is sort of the difference between jQuery and React. And I know this is a bit misleading, but this sort of sells the idea to a non-tech manager. So fundamentally, we were using jQuery and all of those like other frameworks that weren't declarative. And there was a particular way of writing it. Not to say that jQuery is dead. There's still a bunch of downloads. I think 5 million downloads still like every week or so. And React has just like blown it out of the water, right? Like React is the most popular way to build UI right now. Even in the state of JS, like I think 80% of developers know React, is at least the people who answered that survey. So you notice how I mentioned that we don't have a React SDK, we just have a web SDK. And it's fundamentally written in an imperative way of doing stuff like this. And you don't need to worry about like what's happening, but sort of try to follow along on how we would do stuff the JS way. So let's say there's an SDK, you would instantiate it with some constructor and create a client or create an instance. This is sort of a wrapper on your DOM of where you can create tracks. So this is like an async function, which you can call. This returns an array of tracks. So this would give you your mic track and your camera track. This is very similar to your navigator.getDevices and getTracks API. If you want to play this track, it's just one method. You call play on the track, pass it a div. The SDK sort of hooks into getting that div and appending an element and playing that track. We have event listener, so it's like an event-driven API where you can add an on. So this would be like an add listener event, and you can do something when that event happens. So in case a user joins the call, you can subscribe to their video and play their track. Does that make sense? Pretty easy, right? Like this is like a decent normal way of doing API things. When a user leaves, you can call a method, like remove them from the DOM. When you're ready to join the channel, which is start the video call, you can call an async method, call join, pass it some variables, it joins the call. When you've joined the call, you can publish your track so that other people can subscribe to your track and they'll get the event that I showed you before, which is this one. So far, so good. Does this API look okay? Like what would you score it on 10? Like, is it an 8 plus? Show of hands. 8 minus. It's cool. Like you can tell me if it's a bad API. It's all cool. We're discussing ideas and patterns and stuff, right? If this was JS, it's fairly concise, and I love things that are concise and what do you call another word, which is consistent. So those are like my two like biggest things I care about when I'm writing code, and I think this follows both of them. So if we were to use this in React, it's entirely possible, but let's discuss the multiple challenges we'll face. So if you're instantiating a client, this would change within renders. So we wrap it with a ref. Does that make sense why we're doing this? Because each render, we would create multiple clients. There's memory leaks, bad things happen. Again, when we create a track, we want one track. We need to wrap it in a ref. Since this is an async method, I also need to keep a track of when this happens or when this completed. So I need to create a ready object, which is like, hey, the track is ready now. And I need to write a side effect. When the page loads, I want to create a track, do the side effect, when this thing has done, update my state so that I know that track is done now. When this track has done, this track is available, and I am ready to publish, I can now publish the track. And there's an error here which I forgot to fix before the call. You would also need to keep the track of when you've joined the channel because you wouldn't be able to publish. So you see how this use effect would get even more complex, right? So adapting an imperative API, especially when it's asynchronous in a declarative sort of React-like syntax, is not easy, and it opens a bunch of challenges. This is exactly the problem we had with data fetching, which React Query solves, because you would say, let's say there's an API.com and you want to get data from it. Since it's async, you would want to wrap it in a use effect if you want to load it on page. And you would have to keep some state which tracks has this completed, keep some state which checks if this is errored, keep some state which checks if this is stale data after like maybe 10 minutes or whatever. And it's just a bunch of use effects which are not nice to write. And if you've read the latest like React documentation, they want you to avoid writing effects as much as possible. And it's almost like kept in like a different side of the React docs where they don't want you to like even mess with use effect if it's avoidable and attach everything in event listeners, which a lot of the times isn't possible because let's say I want to join the call on a button click, which takes me to a new page. All of these problems happen. So this is first challenge. Does this make sense? Perfect. Second is, how do I interface with the DOM from my SDK? Let's say my SDK does get element by ID and fetches some div and appends a child to the div and plays the video. I would have to get a ref to my div, bind it to the ref, which I actually want the div to be in my like JSX, write another like use effect, which is when something is available, like play this track, make sure the ref is available. This would work because this is an effect. But if I was trying to do this in a layout effect, it wouldn't work because the div wouldn't be like properly binded to the DOM. And you would have other problems like, how do you determine what is the size of this video? So you have to run an effect, bind it, calculate what the video size is, apply some styling, again, recompute and re-render. And it's just not nice writing this code. It's possible, I've done it. Multiple people have used this, but it's not a great experience. Third problem is syncing the state. I sort of showed you how with event listeners, we could just modify the DOM directly. And it's like a great API because we can just add users. When users go, remove users. Here, since we don't like control the rendering of the user, sort of React does, I have to, again, create some state, which is this array, use this array to render my UI, which could be as complex as you want, write an effect, which attaches some listeners, make sure you clean it up after you've done listening to those events. Otherwise, bad things happen, memory leaks, stuff like that. And this is sort of what the syncing the state part of it looks, which is, again, not fun to do. Like, would you want to write this code? Hopefully not. And the last bit, which is super annoying, is writing more effects, which is now I have other async things, which is like initialize video call, which does something like wait for a join thing and wait for a publish thing, which has to happen in order. And since I can't really have an async effect, I have to hack around by creating an effect outside and calling it inside and then doing it conditionally and then making sure React doesn't execute it twice because, again, bad things would happen because you're trying to join the channel, you haven't joined the channel, but you're again trying to join the channel. Does this make sense? Like multiple renders happen when multiple like the effect gets executed twice in dev, in strict mode. So bad things happen. Then again, you have to, since I now have an async cleanup because my effect was async, I can only unpublish first and then leave. This just looks really weird, but this is like the way to do things. And yeah, this is how the state of the SDK was. So we realized that this is terrible and we need to figure out what the approach is for React. We can't say we have a React SDK till we have a React SDK. There's a quick aside here. We built like a wrapper on top of a bit of these things to make like an interim solution before we built out an SDK. It's open source on GitHub. I can leave a link to it at the end. If you want to take a look at it, it's like a 300-line file which just abstracts away some of these things and makes it nicer to use. Not going to talk about it right now because it's like an aside. But the idea that we're sort of solving with the SDK is having a declarative API. How do you modify the DOM? How do you sync the state between your SDK and React? And how do you handle side effects or methods with the SDK within React? All good? Quick break. We're going to talk more code now. Everyone's rested. The UI kit is, again, like a third thing, which, again, we can discuss at the end. But good question. We'll come to it in a second. So React SDK. This is what we've been working on for the last 6 months. If it's in beta, it's open source on GitHub. If you hate something, let me know. We'll fix it. We'll change it. But the idea is it's just hooks and its components, and it should feel fairly familiar. So remember how we had that ref, which we were instantiating a client, adding it to the ref. We just have a hook now. You can call this 100 times. It gives you the same durable client object. On first instance, it creates the client, stores it in some random way. This takes inspirations from React Query, where you have a query key, and as long as the query key exists, you have same state and same data. So that's how we solve it. This looks fine, I hope. Again, more inspiration from React Query. We have a hook called useTracks. It gives you a loading variable, which is state, which is reactive, and a track, which is null by default. And once the track is available, it gives you the actual track object. We have another hook, which is usePublish. Pass in as many tracks as you want. It publishes once. Re-render happens. You don't have to worry about it. It just makes sure it's published while this hook is mounted. There's another hook called useJoin. Pass in a channel name, some props, and it joins the channel. Call it multiple times, all good, nothing to worry about. There's another hook called useRemoteUsers. This gives you a piece of state called remote users, which is an array of users. And you can render your tracks using these components. So your local video track is a component where you can pass in the actual track. You can do cool things like, let's say you want to apply a filter. Go ahead, write a use effect, take your track, modify it, give me the track, I'll render it out. So we're not sort of boxing you in to this API. We're trying to keep it as flexible as possible while feeling React first. Same for the remote users. You would use it like just any piece of state, map over it. It gives you a user. You take the remote user component, which comes from the SDK, pass it the user object, it renders it out. And you could nest it in like a div, style it however you want. All of these are unopinionated in terms of styling and just give you like raw video tags that you can like mess around with. Those 4 pages that you saw of problems, this is all the code you need to build a video call with React. That's like the hurrah movement where this is what we built. Few other cool things I want to talk about with this API is this useJoin feels very limiting. What if I want to, send my server a message that, hey, I'm going to join a channel. How do I know when this has happened, right? What we do is, we also let you pass in an async function to the join, which is executed. And we expect you to return some props. So before we had the room name, let's say there's some room. Imagine you wanted to fetch this room name from the server. Like you have a backend, you want to check which user is allowed to join this room, get the room name. Instead of having to write like a use effect and then get that fetch and then get that data and then render another component, it's possible. We just think this is much nicer to do, where you can pass in a function, do a fetch call your server, get your room, just return that prop to me, and I'll handle the rest. This is one. Second thing we do is we also give you access to the data, which is once you've joined the room, what's your UID, so that you can do stuff with it. We also give you stuff like, hey, is this method loading right now? Are you connected? Did some error happen? And you can do cool things. But I really like the idea of not having to like use this if you don't need it. So again, it's really concise, but we also try to really keep it really consistent. So you can, again, like I was talking about, sort of not boxing you into, just make syntax look nice, but you throw it out because it's not flexible enough. You can do cool things like, hey, let's say you want to do something once you've started joining the channel and it hasn't completed yet. So you can check the is loading state, do some stuff. Again, check the is connected state, do some stuff, tell your server you're connected now. Yeah, we've tried to keep this API like really, really flexible, but also like keep it really, really consistent and like, easy to use. And that's sort of the overall idea of like combining those four problems we talked about, making them easy to use, and yeah. Two quick things before I wrap up, and I promise we're almost done, is when you're designing an API, please keep taxonomy in mind. If we're still arguing about what we should call use effect in 2022, you can spend like 5 minutes to decide what your method name is called. This is a great example of a good API, which tells you that, hey, you probably shouldn't be touching this, but if you are, it's probably fine because you know what you're doing. Some other examples from Swift, which does taxonomy really well, is if I say array.remove, am I removing the 0th element, or am I removing, like finding and removing 0 from the array? Just adding that remove at makes it really obvious, like what you're doing. You're just removing the element at 0. And another one is keeping things like short, like don't overtype things. Is if you're saying view.remove element, it's probably not required because a view is composed of elements. So you can just say remove, and you don't have to be verbose all the time. That's my taxonomy thing from my other talk. And another thing is docs. Who's done this where you look at the code and you're like, I wonder who wrote this absolute piece of trash. And you see your name at the git blame and you're just humbled that, yeah, this is probably me from 2 weeks ago. So document for yourself, because usually you are your worst enemy. And I have a habit of forgetting things. So documentation is great. And there's another comic which I really like from XKCD, which is talking about sometimes if your tool needs a manual which needs another manual to understand how to read the manual, you're doing something wrong. So try to build stuff on the left side, which is stuff that is properly documented. You don't need to refer to the documentation, but it has a documentation if you need to. Again, like I mentioned, the SDK is open source. It's available here. Anything you don't like, we're happy to take feedback, change stuff. That's all for me. Thanks for your time. Build cool things. Any questions, you can reach out on Twitter. Any questions right now, you can again like ask me stuff. You had the